Hello, welcome back to my channel. Today we are going to solve Leetcode problem 62, unique paths. Basically we are giving a robot at the start point, and the robot can go to the right and go down, but cannot go to other directions. And then the robot will go to the finish point. So we are going to find how many different combinations of the route. So for this problem I'm going to use a DP and math. So for the DP method, if we are going to check the finish, normally we need to combine with the top and from the left, because there are only two possible ways. So the robot can from the top go to the finish, or from the left go to the finish. So I'm going to plus this one and this one. So for each one of them, I'm going to plus one by one until to this point. So this is basically the DP method. For the DP method, the time complexity is just m times n. And for math, I'm going to use a formula. It is just O1 time complexity, but the space complexity is always be O1 because we didn't. The space complexity for the DP method, it is OM times n because we defined a DP to the array, and for math it is O1 because we didn't use actual memory. Let's check the m and n. It is a maximum 100. Now let's just code it. So as I explained, for the DP method, I'm going to use the top down. So for example, this point, it can come from top and come from the left. So how many ways from the top? So top, this one is only one way. Here is only one way. So in this point, it has two ways. So like my explanation, I'm going to try the DP method first. So for the RC equals to m and n. So m is row and n is a column. I'm going to use my definition of the variables because for dealing with matrix problems, different platforms have the different definition of this m and n, but it doesn't matter. For me, I just use my system of row and column. And then I can define my DP array. So the DP array inside, I'm going to define as a 1 because the first row and first column should always be 1. There's only one way, like this point. You can just go from this way. So there's only one way. And also this point, you can just go from the start to this point. There's only one way. There's no more. You cannot find some ways it can go from here and go back because it's not the case. The robot can only go to the right or go to the down. It cannot go to other directions. So we can use this 1 times how many columns, and then we're going to check how many rows. So for R in range, capital R. So this is our DP. So this is our DP array. Then we are going to use the transformation function inside of the DP array. So for R in range 1 to capital R, and for C in range 1 to capital C. So the dprc should equal to dp r minus 1. So r minus 1 is at the top, C, and plus dp r c minus 1. C minus 1 is to the left. Now we can safely return the DP array. Now let me run it to check if there are any mistakes. It's not valid value. We are not going to return the DP array. We are going to return the value, how many different ways. We are going to return a number. So it should be DP minus 1 and minus 1. As you can see, it works. Now let me submit it to check if it can pass all the testing cases. As you can see, it passed all the testing cases because m and n is not a big number. It's pretty fast. Now let's try to use the math method. So for the math method, it's also easier to code but difficult to think. So the math method will just be the factorial m plus n minus 2 divided by factorial m minus 1 times factorial n minus 1. Let's run it first to check if it works, and then I will explain why we can use this formula to finish find all the different paths. Just use one formula. As you can see, it works, and it's pretty fast, nearly 100%, because this is just the O1 solution. Now let me explain it for the math method. So let's have a look at this picture. So we need to check how many different combinations of rows and columns the robot can go. So for example, the robot can go 1, 2, 3, 4, 5, and 6. It means there are 6 slots of rows. 1, 2, 3, 4, 5, 6. So there are 6 of rows slot the robot can go. What about column? Can go down, but in different places it can still go down and go down. So how many columns? So the columns there are only 2. So what are we gonna do? We just gonna check how many combinations of this arrangement. So for example, this is one arrangement, and we just gonna check how many arrangement. For checking the arrangement, it is the permutation. So for the permutation, if there are duplicates, we need to check the duplicate. So for the permutation, it is let me put it here. So for the permutation, we need to check how many combinations of this, for example, this n minus 1 plus m minus 1. Let me check the permutation ways. So for the permutation, we need to check how many permutations in total if they are all unique. So for example, if this R and C are always unique, it is m minus n plus 2 factorial. Because if they are all unique, we know that if we have 3 numbers, it is a factorial 3. So here, m minus 1 plus n minus 1, for example, this is like 8. Because 10 minus 2, it is 8. So 8 factorial, it's all the permutations. But inside, according to probability, so we have how many R's? There are 6, so we need to divide it by this m minus 1 factorial. And how many n's? There are 3. We should divide it. N, there are 2, so there are 2 sets, so n minus 1 factorial. So this is a kind of probability. So this is a kind of permutations of this R and C. But if R and C have duplicate in mathematics, the formula is m minus n plus 2, this factorial. This factorial is all possible ways. For this one, it is 8. And divided by the duplicate factorial times another duplicate factorial. So this is m minus 1 factorial times n minus 1 factorial. If there are more numbers, maybe there's a RC, maybe there is a BA, we have to divide it by the duplicate. If there are 2 B's, so there will be 2 divided by 2 factorials. Here's the times. So this is the math, basically. Thank you for watching. If you think this is helpful, please like and subscribe. I will upload more Leetcode problems like this. See you next time.